Hi everyone, nice to see you all. And let me start sharing my screen. Awesome. So what I'm going to spend today, next few minutes is talking about event-driven orchestration and building services through that. And if we have some time, hopefully we'll get through a demo as well very quickly. But let's talk a little bit about event-driven architecture. So, this is essentially what is event-driven architecture is, it's a software that reacts to, business or system events that drives the business flows. Typically in near real time or close enough to the real time as the events are happening, things are moving forward. A good example is, let's say a user adds an item to a shopping cart. So that's an event that triggers some backend process, right? Things like, for example, maybe notifying kind of some system to check the pricing, to kind of save the state into a database and things like that. And the way it is typically works is, or implemented is, you have set of publishers. These publishers are different applications which are publishing events. You have a message broker infrastructure that is responsible for kind of maintaining various topics and queues. And then you have consumers which are consuming from one or more of those, and then, acting on it. And when you are building event-driven applications, your typical goals are, the following. One is, you typically want to reduce the tight coupling between the services, which means, when an event is triggered, as a producer, you just trigger an event. You don't necessarily have to worry about who is consuming this event, what is going to happen, and so forth, right? Similarly, as a consumer, all you do is you focus on an actor model where, like, when an event is triggered, you act on an event and do something rather than doing anything. So, for example, let's say if in our shopping cart example, if the user does a checkout and the payment is completed, that event gets triggered, and then let's say you have kind of a consumer that listens to all the successful checkout events and sends out an email to the user with order information and expected delivery times and whatever not. It doesn't really matter which application that triggered that event and so forth. This allows you to kind of build a lot more reusable components. And this also means that you are able to kind of very easily integrate across heterogeneous systems. You don't necessarily have to have every part of the system written in the same language or a framework or something. Like my kind of front end could be written in Node.js that is sending out events, and my backend could be written in Java, Golang, maybe Python as well, that takes care of the things. Another advantage of having a message broker infrastructure is, it enables you to have very long-running asynchronous flows. If you think about maintaining an e-commerce system, an order is a long-running process. It could take anywhere from a few hours or to a few days to deliver your item and complete the entire order flow. So the system kind of inherently lends itself to building asynchronous flows, which can be scaled very easily. Because now what happens is that services are independent of each other. Let's say I have a service that reacts on an event to send out an email. Now this can be reused across multiple different systems, not just e-commerce service, but also maybe when the user submits a return request or has a query on their purchases and things like that. And probably this is a much more high volume system. I can scale it independently from everything else. It doesn't have to be very tightly coupled. So these are basically typically the goals that you have when you are building applications which are event driven. And as I said, right, like just to kind of reiterate, they typically rely very heavily on a message broker infrastructure to scale themselves and manage the state and all of those things. And typically, one way to kind of build this is kind of through peer-to-peer system, right? As I kind of shown here, like, you have applications which are acting as message producers and applications which are acting as message consumer, and they are all acting on its own in publishing and consuming messages without any coordination in between. That's happening kind of implicitly within the code and inside the application flows. But that typically tends to run into several problems. And here is some of the issues that you tend to kind of start to encounter as you kind of start to make them more complex and scale it up. One is we talked about the goal of having, reducing the coupling between the services. But what tends to happen as you kind of increase in the complexity with things like choreography is that, it encourages tight coupling. Even though your communication is not synchronous and is going through message bus, the system start to kind of become aware of other components in the system and act basically that. Like, take, for example, a good example will be send email. If an event comes to send out an email, I need to have some more context about what is this about, right? Is it about order? Is it about a return request? Is it about a user query for a customer service? And now I'm starting to kind of put more logic into that. And, I have my services that is talking to a different database and so forth, right? Other thing is that when you are relying on a message broker, oftentimes, you end up with a protocol dependency, like a JMS, for example, right? Let's say if you're using JMS, suddenly you are stuck with the Java-based ecosystem. It's much harder to kind of make it work with, say, Golang or an upcoming language like Rust. And if you try to implement the same thing using things like more open protocols like HTTP, you tend to find that, no, it's much harder to kind of build it that way. And then what happens is, what everybody dreads, right, which is kind of the notion of a distributed monolith. What happens when every service starts to know about each other, and the routings are starting to be written in the code itself? Like, I know then I should publish a message, so that, like, somebody can pick it up. To give you an example, let's say once I place an order, I need to notify the user, so I'm going to publish a message to send an email, which means now I know that the email has to be sent. What if I want to do something else before sending out an email? Now this code starts to kind of flow starts to get kind of embedded inside the code, and that kind of gives you rise to a distributed monolith. What tends to happen is that you end up building a huge monolith that is distributed across many services. And now what happens is, as a business user, as a process analyst, or even as a developer, when you want to know how your services are working, it is much harder to kind of visualize a track process flows, because everything is happening in a distributed environment, in a different systems and services. Something is running in Java, other thing is running in Python, something might be running in container or VMs and so forth, or as lambdas. So now what do you do there, right? Like, and now you have to kind of build out tooling, you have to maintain some database where you can send the state, or you rely on a combination of some sort of metrics and analytics system to kind of manage these things. But what happens now is, who really owns this process flow? Who is the source of truth for the state? So take, for example, if I have an order management system, and given an order ID, if I want to know where is this order in the kind of entire life cycle of the order, who owns that tracking? So now you tend to kind of build a separate database to track application state, which is very ephemeral in so many ways, right? Because its usefulness is only as long as the order is active. Once it completes, typically the data is already stored in the business system somewhere, and that's the source of truth. But now you have kind of duplication of the logic and data. So this is how we used to do things at Netflix for a long time. We had a PubSub system that we had built out using Cassandra and Zookeeper. This was a fully distributed message broker system handling hundreds of millions of messages per day, which is the reason why it was custom built. And hundreds of microservices relied on this. Where it started to break was everything that I mentioned earlier, right? What happens when something goes wrong? When happy paths are typically okay, that doesn't give you a lot of heartburn. It is those kind of scenarios where things don't kind of work as expected, when you have complexity that keeps increasing, which is where you start to kind of realize this is harder to maintain. So we decided to kind of start thinking about what should be the successor to this, right? And of course, orchestration definitely solves, in fact, pretty much all of these issues. But then, it also kind of brings in a single point of failure, which is that, if your orchestrator goes down, then everything kind of comes to a halt. So, we started to kind of build out things that would be fully distributed, should be cloud native, should be able to handle a large volume to, support outgoing system, and has to be fully polyglot in nature. So Conductor essentially does that. It is that successor to a traditional PubSub or a choreography-based system that allows you to build very powerful event-driven applications. And it addresses some of the shortcomings of peer-to-peer messaging systems with a message broker infrastructure. Not to say that Conductor does not have a message broker, but now instead of programming against a message broker, you are programming against a much higher level API constructs that allows you to kind of not worry about message broker infrastructures and low-level stuff. And it also removes the coupling between producers and consumers. So you get a truly decoupled system where you can independently change the shape of your business flows without necessarily changing the code and having to worry about dependency management. So how do you build event-driven applications using Conductor? So one is, when you think about design patterns and software designs, what Conductor does is it helps you implement orchestration saga pattern, right? Where you have long-running sagas, but doesn't have to be necessarily long-running, right? It could also be a very short-running process that completes in a few milliseconds and can be executed completely synchronously. And you have consumers which are completely single responsibility, which means they don't necessarily have to maintain a state beyond their own local database for transactions. And all the routing is maintained by the server. So, as a producer, all you do is, you just complete the task that you are supposed to do. And server takes care of understanding that, no, this is done, what should happen next, publishing the messages and everything. And it takes care of, maintaining the message broker infrastructure via distributed queues. So that allows you to scale to, very large volume. But more importantly, it gives you very full-blown visualization, which means that now you are able to actually visualize exactly how everything is kind of wired up, how your data is flowing across different systems. And it gives you a nice UI that lets you, visualize your entire code graph as to, how you have wired things together and debug things and whatever not. And finally, it's fully distributed, which means there's no single point of failure. You can bring down the entire server and your system will still be operational. Of course, until one of the pod comes online, things will not get processed, but you don't lose data, you don't lose state. And more importantly, as you kind of scale it out to higher availability zones and nodes, it kind of keeps adding more and more nines to your availability. So typical way to kind of build your event-driven application in Conductor is via two things. One, your entire application routing logic is represented as a workflow. And workflow essentially acts as a state machine for your application. Take, for example, if you are talking about a loan processing application or an order management system, the entire kind of application state can be modeled and visualized as a workflow and a state machine, right? Every box here in this in the diagram that you see here is a service, and the service can be either an HTTP endpoint if you are invested into microservices world, or it could be a service worker, which is basically a very simple abstraction on top of your existing language framework. So take, for example, if you are building using Java and Spring Boot, you annotate your existing bin methods as worker task and give it a name, and they become part of the components. Now you don't have to worry about, bringing up a load balancer, setting up the API security policies, having an API management layer and everything, right? This completely goes away until and unless you really need to expose this as a service, which oftentimes is not the case. You don't have to worry about those things. The other advantage of this is that it basically follows kind of a, so to speak, push notification kind of a method. So, things like, for example, let's say if a particular worker, when there is a mismatch between the producer and a consumer, all the arrows that you see here are in the end distributed queues, which means, the messages are kind of held there until, some consumer is ready to come and pick it up. So, it automatically gives you those semantics around being able to handle rate limiting, being able to handle and throttle the data or, process them at different cadence. Now, to build this flow, you have kind of several options. Conductor is very flexible from that perspective. You can design using UI. A lot of times that's the best way and the fastest way to do that thing. The whole thing is kind of represented as a JSON-based configuration that you can essentially check into your version control. There's a framework that lets you kind of do testing. So, you can write JUnits or other unit testing on top of it to ensure that, your flows are well tested, just like your code. It essentially is your code, right? or you can write the whole thing in code if you want to write, and if this is completely dynamic, right? If this cannot be predefined, and if you want to do this dynamically, you can do that as well. I'll skip over the slide, but Conductor is open source. So, I will highly recommend checking out the project, search for Conductor open source, and, you should be able to find the links to Conductor. If you like the project, definitely, check it out, give it a star. It definitely helps. But Conductor is used across wide variety of kind of industries today. Here is some of the list, but let's jump onto it, right? Let's talk about one example. So we talked about event-driven architecture, right? And when you think about eventing, so this is the UI that lets you kind of monitor your state of workflows and everything. And you can see, how things are wired, what's going on, and things like that. Now, one area where it really kind of shines is when you think about very let's take a look at an example of a workflow that, take for example, let's say I have an application flow which makes calls to a whole bunch of HTTP based services, some of them in sequence, some of them in parallel. If you were to write the whole thing by yourself in the code, what could happen is that, like, when you are making call to a service could be down. Now you have to kind of either hold the data somewhere and retry where it left off. Once service is up and running, somebody has to keep retrying and all of those things. With Conductor, essentially, every service that you write acts on an event, right? An event will be triggered by the server automatically once, its previous state completes. So, the events are produced by the server. All you do is you focus on consuming the events and, acting on it. And you can wire up things in multiple ways, right? You can have kind of loops, you can have parallel processing, you can do sequential, and more importantly, you can kind of exactly see, where things are running, how things are running, and so forth. So, like, for example, I know exactly this particular worker ran on this pod. It took 63 milliseconds to complete its job, and so forth. Now, another advantage of Conductor is, no eventing system is complete without integration with other eventing systems. So, it also lets you kind of publish events to existing message broker infrastructure that you might already have, right? So take, for example, let's say if you have an existing Kafka-based system, and you have applications that are consuming from messages from Kafka, and you want to integrate, Conductor makes it super easy to do that. I'll take an example workflow. I'll run the workflow here and show it to you. But this is an example of a task. So Conductor has support for something called event task. And events are basically something that gets published to an external system. So like in this case, I'm publishing an event to a Kafka topic. And what it does is, it publishes an event to Kafka topic. It waits for that event to arrive. And once the event arrives, it completes it. So, you can build very powerful integrations and coordinate across multiple systems like Kafka, RabbitMQ, SQS even. So, when you are kind of going through more serverless model, for example, for your eventing like SQS, one problem that always comes is, okay, I can use SQS to publish and consume messages, but how do I build very powerful applications? Conductor kind of solves that problem for you. So I'll stop it here. If there are any questions, happy to take those things. If not,
thank you, Viren. Yeah, actually, I have a question for you that can benefit for the audience today. You just talked about the integration with existing systems. Let's say I already have an application that exists and is deployed since a while. Is the process, if I want to benefit from Conductor and all the functionalities that you showed in addition to my messaging system, is it like a new development, or can it be something that is progressive?
It can be progressive, because like if you think about it, right, like how many times do we build new applications versus how many times we are changing existing applications? So, Conductor lends itself very well to those use cases where you are essentially changing parts of the systems or enhancing them. So, what we call it as a brownfield migrations. And Conductor also is not very opinionated framework. It lets you define your own frameworks and architecture the way you want it, which means that, let's say, you don't necessarily have to have microservices. We all know, right? Like lately, there has been a lot of microservices across many organizations. So, if you are writing everything in a single application, you don't have, and you're writing more monolithic applications, Conductor is just completely fine, right? Instead of now one function A calling function B directly, you can kind of route that call via Conductor, and it takes care of managing the durability of the call for you. But now you still have a very simplistic programming model that you can work with. And similarly, if you have an existing application and you want to introduce one new application flow that is now you want to run it through Conductor, you can just introduce one very safely. And as I mentioned, right, like you can take your existing code base and annotate that with the kind of Conductor APIs, and it works with your framework, which means you are not changing your framework, you are not changing your code base, how things are implemented, everything just works as it is. But suddenly they become a lot more powerful, right? It gives you that superpower capabilities of being suddenly durable and elastic.